Okay, so we're working our way through chapter we're going on to just sort of learning the rules. But sort of let's get some concepts going just because. So this video, we're going to be looking at trig derivatives. And so let's go that 1, negative 1, 1. I'm going to stack them up here. Yeah, they're definitely getting stacked up. Okay, so I'm going to graph y equals sine x. So y equals sine x. Now on this graph, I'm going to graph, we've sort of gone through this before, but I want you to see it. We're going to graph y prime. Well, y prime is going to be the derivative of this. It's going to be the slope of this. So right here, it's going to have a slope of 1. Right here, it's going to have a slope of 0. Right here, it's going to have a slope of negative 1. Right here, it's going to have a slope of 0. Right here, it's going to have a slope of 1. And right here, it's going to have a slope of 0. So I'm going to get this function here. Roughly. And that, as you should be able to see, is cosine x. So the derivative of sine x is cosine x. Well, now let's find the derivative of cosine x. Well, right here, that's got a slope of 0. Right there, it's got a slope of negative 1. Right there, it's got a slope of 0. Right there, it's got a slope of positive 1. Where do I want to be? I want to be like right about there. Right there, that's where it should have a slope of 0 if I didn't shift it over. And right there, it's got a slope of negative 1. Let's go, that's the slope of negative 1. Let's pull that out over there. And that's got a slope of 0 right there. So then what I'm going to get, I'm going to get progressively worse in my drawing as I go down. Well, what's this function? Well, this function is this function flipped upside down. Well, how do I flip that function upside down? Well, I put a negative in front. So the derivative of cosine x is minus sine x. Let's keep going. What's the derivative? What's the triple derivative of sine x? Or what's the derivative of negative sine x? Well, here it's got a slope of negative 1. Here it's got a slope of 0. Here it's got a slope of positive 1. Here it's got a slope of 0. Here it's got a slope of negative 1. Here it's got a slope of 0. Here it's got a slope of positive 1. And so we're going to get and that is going to be negative cosine x. One more time. I'm out of room, but we don't need any more room. That has a slope of 0. That has a slope of 1, that has a slope of 0, that has a slope of -1, that has a slope of 0, that has a slope of 1, that has a slope of 0. The derivative of negative cosine x is sine x. So you've got this thing. So here's your little chart for taking the derivatives. Whatever function you've got, if you want to take the derivative of it, you just go find it on your chart and take the next one down on the chart. Derivative of negative sine x is negative cosine x. Derivative of negative cosine x is sine x. Okay. Now, just like e to the x, this can get kind of boring. So we're going to tie it in with some other things. So we're going to throw in some chain rule problems on this. So throwing in a little bit of a chain rule. Y equals sine x cubed plus 3x. What we're going to do is we're going to say y equals sine of u equals x cubed plus 3x, dy du is equal to cosine u, du dx is equal to 3x squared plus 3. And so we're going to say dy dx is equal to du dx times dy du is equal to 3x squared plus 3 times sine of u, and u is x cubed plus 3x. And there you go. Now, I did a more complicated one first. The one that I think that this is one that I wish I could make you watch this one a million times. This is one, let's do this one. This one, calculus students just botch it all the time because they don't see that it's a chain rule problem. Right now I'm telling you it's a chain rule problem, so you're seeing it's a chain rule problem, but you're going to have to see that it's a chain rule problem when it's disguised on a test, because for absolutely sure at some point in time there's going to be a problem where they just throw that out in there and they don't tell you it's a chain rule problem, and if you don't realize it's a chain rule problem, you're going to get it wrong. So sort of following my my lead from previous, what people will do on this one is they'll do, oh, so that's just dy dx is equal to negative sine 5x, and then they'll just move on from there. That's not the whole story. You have to say y equals cosine u, and then u equals 5x, and then dy du is equal to minus sine u, du dx is equal to 5. So dy dx is equal to du dx times dy du is equal to 5 times negative sine of u. Okay, now after a while we get sick of writing out all this notation, and so we learn how to go really fast. So we say y equals minus cosine of x squared, and because we've gotten really good at our trig derivatives and our chain rule, we're going to go, oh, that's just going to be 2x sine x squared. And we say y equals sine pi x minus cosine pi x. And we're going to say, oh, I know how to do that. That's going to be negative pi cosine pi x, and then positive pi sine pi x. So it's going to be pi sine pi x minus cosine, or pi cosine. Okay, and that's sort of really interesting to look at, and that might be one to do on a graphing calculator at some point in time. But next thing that I'm going to do is we're going to come in. Oh, hang on. I think in the next video we're going to continue. That's enough for this. But we're going to talk about some tangents and cosines and tangents, cosecants, etc., etc.